Hey folks, going to do a quick update here on the power supply, the first of two, most likely. Just want to show what I've done. There's a lot of videos on YouTube about converting a computer power supply to, most of them are to benchtop supplies, which isn't exactly what we're doing if we're doing model railroading. A lot of those folks are doing it to make different voltage available and not be loaded all the time as basically as a supply voltage. But what we're going to do is actually mostly have our stuff loaded. So there's some things I learned as I went through. This is the power supply here. I'll show you a little bit more. I bought that on eBay for 18 bucks, free shipping. What I decided to do was bring down the 12, this is 12V2, 12 volts, 5 volts, and 12 volts. I didn't bring all the wires down. I brought down all the 18 gauge. And very important, I don't know how well this might show up, but in each of the voltages there's a smaller sense wire, I believe that's what it is, that needs to be connected. I think I damaged one of the power supplies when I didn't do that. So there's the sense for the 12 volt, the sense for the 5 volt. This 12V2 circuit doesn't have it. And the orange, I didn't use. I kept all the cables just in case I ever want to do something with them. Basically the smaller gauge, the 20 gauge, and all of the orange, which are the 3.3 volts, I did not use, but they're there. Again, there's the sense. It's tied in here. It's soldered together and tied in. Very important. And I think I damaged one of the power supplies because I didn't have those attached. There's some other cables that I didn't use. There's these right here. It's like a gray and I guess I'll call it a purplish. I think it's like power good and another 5 volt circuit. You could use them for 5 volts if you wanted to. Not a whole lot of current capability on them. There is also a negative 12 volts, and what I decided to do was actually run a light. I had some spare leftover stuff in the toolbox from other items I had bought, so I decided to use that as a power on indicator. Basically, it just goes green, and it's wired from the negative 12 volt to one of the ground wires, and that'll show green when the thing's on. You could also do it with the other wires, like I said, the 5 volt wires. You could do it, or off the 12 or the 5 volt, the main if you wanted to. Obviously, if you use an LED, you need a current limited resistor in there, but that's pretty obviously well known to folks. So, but you could do it. I just decided to use this. I bought a little bracket at the hardware store, bolted it down, and the light I'm using is actually, you can read that there, pardon the shadow, green. They have green, yellow, or red, so whatever your choice of colors. To me, green means go, so I went ahead with a green one. And they're from All Electronics, 12 volt, so they're good for 12. No limiting resistors or anything needed. Then after coming out to some terminal blocks, I then went down through a fuse just to have a little bit of protection. This one's jumpered for now. You'll see why in a moment. The fuse is out, and these are fused. Right now it's 7 amps. There's tons of power out of this thing, probably more than we'll ever need, but I did put a fuse in there for some protection, and then another terminal board. And this is kind of how I'm going to run my buses. I'm going to have a 5 volt bus go this way, a 12 volt bus go this way, and then a 5 and a 12 go the other way. The 12 obviously being for things like tortoises, building lights. Some of the CMRI stuff needs 12 volts, and the 5 again for a lot of the CMRI stuff. All the signals use the 5 volt circuit for the LEDs and the various signals and whatnot. So that's that. So quick break. Let me show you the information about the actual power supply. Alright, here's a power supply. It's available on eBay. It's where I bought this one. If you search StarTech or something like that, it comes up. Very good. I'm actually pretty happy with it. It is about 18 bucks, free shipping right now. I'm probably going to buy another one to have a backup, especially with free shipping. And again, the ratings are available on the site. But you can see here there's plenty of oomph in this thing. 3.3, which I'm not using, 30 amps, 5 at 45 amps, 5 volts. There's a 12V1, 12V2, 16, 17. There's a negative 12 that I'm using the light at 1 amp. That other one might be the +5, that purple wire, 2.5. And the gray, I think, is power good. Black is calm. And the PS remote is another one. Oh, the one thing that I did forgot to mention, I need to go back and show you that real quick on these. In order to get them to turn on, you need to connect this green wire to ground. Normally it's connected to a motherboard, and that sends the signal back for the power supply to actually turn on. So you make sure that's connected, otherwise it won't turn on. I did try that, and it really does. It is true. Just connect it to any of the black wires. I did it here at the terminal board. You could do it in the back somewhere and just tie it off as long as it's connected. That's very important. This is nice. You might, if you're looking at stuff on eBay, or I'm sorry, on YouTube about power supplies, a lot of them say you need to add an external resistor to load it to a certain percentage. This one you don't, I believe, because there actually is right here. There is a resistor in there. Probably never going to be able to see. I don't know. Maybe you'll be able to see it, but 7.5 ohm, 10 watt resistor, and it's on the 5 volt rail. So you cut that green wire, you turn the switch, the fan fires up, and it turns on. So it works pretty nice. So I think that takes care of that. And again, often, even if it didn't have that, eventually, when we're in the model railroading world, we're going to use it to actually power stuff. So it will be always under load. And obviously, the more you add, the more lights, the more signals, the more load you're going to get. So I think you probably wouldn't need that. Maybe initially, if the power supply you have didn't have that, or wouldn't turn on or stay on if it wasn't loaded. You could always add one. I have some. I'm going to show you how I loaded it up to show you the voltages that come off of it. But I think for us, eventually, you probably could take it out once you get the layout actually powered up. Because unlike a lot of the guys using it for the bench tops, they might not have it loaded until they're actually doing some tests or doing some breadboarding or something like that. But we're going to turn it on, and all our stuff's going to be powered up. So there's the other one I have for the next power supply that I'm going to make, and that's obviously this is the one that I think I damaged, but I'll be able to salvage it for parts and whatnot. And I got a nice fan there in the back that works pretty cool, so I can cool things off. But anyway, that's the inside of it. Looks relatively well made. Like I said, everything's kind of soldered over here. I didn't cut the wires inside. Some of the videos say cut them inside. It's just too crowded in there, and I just didn't want to deal with that. So basically, again, what I did was just leave all the wires. I did cut these short just to make them a little bit neater. Cut these short, and the rest I just kind of trimmed. They're all tied together. Just snip the ends off. All the connectors, you got to cut all those off, which you'll see, and did it. So let's go ahead and going to pause here for a moment. We'll fire it up, and I'll show you the voltage we get. Okay, I'm going to do the best I can here, hand holding it, so please excuse the shakiness you might find, but so I got it plugged in. This one does come with a power cord, which is kind of nice. So you go ahead, there's a switch here on the side, you just turn it on, the fan kicks on. Got my handy dandy little LED indicator that it's running, at least the negative 12 volt rail is good. So what I'm going to do is kind of go down, we'll just kind of see what the voltages are with no load right now on the different rails. So we'll do the 12V1, see 12.19 or so, and we'll do the 5 volt, 499, 498, and the other 12 volt, about 12.19, so 12.2, pretty consistent. 499 and the 12. So that's no load. Now what I'm going to do is actually use some of those load resistors, very similar to the one that you saw inside, and load it down because the voltages do change a little bit. So let me hook that up, and I'll just show you that so you're aware of how the voltages do drop. And actually the 5 volt rail goes up a little bit, but we'll show that in a moment. Stand by. Okay, we're back. So I have, like I said, I got 2 of these load resistors. 7.5 ohm, 25 watts. I also, the reason for the fuse being out, I put an ammeter in the circuit. This is just a cheap ammeter that I had, 0 to 10 volt DC. I was thinking about actually putting one in, but just didn't have the time, and maybe we'll add one to a panel later on. It will be kind of interesting to see the current draw, especially as the layout progresses. But So again, so right now it's powered up, no current, and for example on the one rail, again we got the 12.2, 499, and 12.2 on the other 12 volt rail. So what I'll do is very simply just load up that 12 volt rail with this. It's just connected with some jumper wire, and then the green over to the ground. So I'm going to just load this up. Okay, and you can see now we're pulling about just about 2 amps off the 12 volt rail. And what happened to the voltage? Well, let's find out. We'll check this rail here. 11.34. Okay, so it dropped. And the 5 volt rail, check that. Oh, it went up a little bit to 511. Okay, and the other 12 volt rail, 11.62. So you can see the 12 volt rail drops and the 5 volt rail goes up when you load it at about roughly 2 amps or so. So now what I'm going to do, I have another one, alright, and all I'm going to do is load the 5 volt rail. So we're loading the 5 and the 12. And just bear with me here, it's kind of tough to do one-handed. I don't want to short anything out obviously. But I'm just going to go ahead and take this and load the 5 volt rail. Now see, the current doesn't change much because I'm not measuring the current on the 5 volt. But let's see what happened to the voltages. So now we're going to go back to the first one. Up a little, 11.6, okay. And the 5 volt rail down to right about 5, so that's going to be pretty steady, which is probably good for the electronics and whatnot. And this other 12 volt rail, 11.8. So you have 11.8 and we have 11.6, pretty close. And that's with, you know, this particular 12 volt rail loaded and that one unloaded. So let's just, for fun, we'll unload the 5 volt. And I will see what happens here. I'll load the other 12 volt rail. Not much of a change in current, but let's see what it did. So now I'm loading this 12 volt and this 12 volt. We'll measure that. 11.31, that dropped. 512, so that went back up a little bit, not loaded on the 5 volt rail. And 11.5. So you see 11.5 with that rail loaded. 11.3 with this rail loaded. At roughly 2 amps on the one rail, so they're both at about 2. So I'm pulling about 4 amps out, which is, okay. So I just want to show that. Just be careful, these resistors will get hot. And again, I'm not sure this is the exact kind of load that we're going to have. I know the tortoises, draw about 20 milliamps perhaps, the stall machine, so I'm not too worried about that. I did try it with a tortoise, it worked fine off the 12 volts. Like I said, so that's what I did now. The ammeter, again, that's just sitting there right now. Will be kind of nice to have, but I didn't add it onto the board here to be able to look at it. I'm going to show you now. I'm going to show you why on the layout why that connector and the switch is on the side like that, and I didn't orient it straight up and down the board. It's sitting, obviously kind of sitting this way on the board, and there's a method to the madness. So let's go over to the layout and I'll show you that. Okay, so here it is in the layout. I basically just put it on a small little shelf here that is slidable. It's not on rails or drawer slides or anything fancy like that, which of course you could do if you were a little more inclined than I am, or actually a little more talented than I am. But that sits there. I have it powered. It's kind of a mess right now. It's just drooping right now, but it's over to the individual circuit, or this that is powered by this switch here. This actually powers the entire layout. So you flick that, and then that will come on. As long as everything else, you'll hear the engines probably rev up pretty soon that I have sitting on the layout. But so that's that. And then this way, I'll probably have it sitting here. Yeah, there goes the. He's firing up there. Steve-O was running 4-engine consist, having a little bit of fun there. I noticed, of course, I didn't plan very well. You can see my buses are going to go right through there, so I'll probably just drill some holes. That'll help guide it in. But it's set at a level. Let me just kind of get back here. I wanted to be able to work on it comfortably, So I have this handy little stool that I bought at Lowe's, and basically the way it's located, I can kind of just sit down and work on it to wire it up. Not that you're going to be doing a whole lot of wiring once you get it actually installed. It'll pretty much just sit there. But if I ever want to come back and run more circuits, I'll do that. The reason that I had, sorry for my shadow there, the switch and power on the left like that is if I ever had to take it out, it's just a little bit easier. You know, you can reach in, pull the cord out or turn it off, and then slide it out, take it to the bench to work on. If it was in the back, it just would have meant crawling underneath the layout to get behind it. So, just seemed a little bit easier to me. Again, eventually, when the fascia's up and we have a curtain hanging down, you could always just kind of pull the curtain back and say, "Yep, got a green light." And if you ever had to get a fuse for some reason, you could slide this out. Although, if I actually go ahead and drill the wires to go through here, it won't be very slidable. So maybe I'll even rethink that. I'm glad I'm making this video. Because I do want to be able to get it out relatively easily. And once I drill holes and go through there, that it's not going to happen. So maybe I can always push it back a little bit, favor it toward the back, which should be fine. And one clears. I probably get both of those to clear, so that might be just fine. So that's that. Like I said, it's all controlled off of the main switch. So you turn the layout off. Engines go off, and it goes off. So every time you turn the layout on, you'll have your power. So that's what I did. Just wanted to let people know about that. I've seen a lot of stuff I saw in the video about converting those ATX computer power supplies. And you don't have to buy one. You certainly could get one out of a used computer, an old computer, a desktop computer, obviously. I have an older one, but I'm probably going to use it for the CMRI system. But you certainly can. There's no reason you can't. They have a lot of power, a lot of different choices for voltage. Again, this particular one I liked because it seemed to have that internal load resistor that allowed it to come on. And we'll see. So I'm going to run basically 2 circuits around that way underneath the layout. It's going to power mostly this side in there at Lake City. Whatever we do scenery wise in here, probably 12 volt for the lights, all the signals. It'll then power what eventually will be Lake City, and now it's just a work area. And then pretty much over to the pull-out. The other one that I'm going to make is going to be sitting up under the transformer factory, which will be in here, which will probably be the next largest, eventually, power draw. And then I'll run a circuit around to handle this side of the Eugene yard, and around this way for the various machines, control panels, signals, etc., over to there. So that's the next thing I want to do is I need to get these buses run so I get power out to the switches so I can actually start moving some switch machines except by hand or using 12 volt batteries to move the switch machines, which works fine, but it's a little cumbersome. And then get power into here so we can start hooking up and doing the switches and LEDs and lights and indicators and whatnot. So that's that. Just wanted to let folks know how we did that. Again, it's a little bit different than I think than most of the videos you see where they actually did it as a benchtop power supply. Very similar, but again for us it's going to be pretty much loaded all the time. So that would seem to work pretty well. That power supply available on eBay, 18 bucks, free shipping. I'm definitely going to go buy another one, have it as a backup. So there you go. Any questions, comments, concerns, anything you think we did wrong? Any other great ideas? Like to hear them. Let's help each other out here. But I'm looking forward to seeing how this works. And I'll report back once I get the bus run and measure actual voltages in the areas. We'll see how the voltage drop is in the lines and whatnot. But probably going to run 12 gauge wire, at least 14, maybe 12. Depends if I feel like fighting with a 12 gauge wire, just to hopefully eliminate some voltage drop. But it's not that far a distance, so that's it. That's the update for now. So hopefully it helped out somebody, and have fun in model railroading.
stinky train. That's all, folks.